So now in this exercise, we're looking at negative rational exponents. The relationship is essentially the same as it has been in the past when we're not looking at rational exponents. What we're going to use is a to the negative n equals 1 over a to the n. And then we're just going to be simplifying whatever's left in the denominator. We do have to be careful where the negative signs are, however, and that's what we'll see in this simple example. With part A, we have negative 64 to the negative 1/2. Using our relationship of a to the negative n equals 1 over a to the n. That means this equals 1 over negative 64 to the 1/2, which equals, converting that to radical, 1 over the square root of negative 64. Uh-oh, we have an even root. There's an invisible 2 out here, and there's a negative symbol underneath the radical. That means with this, there is no real number, because we cannot take the square root or any even root of a negative value. So part A, negative 64 to the negative 1/2, is no real number. Now with part B, we have what looks like the same problem, only we have 64 to the 1/2, negative 64 to the 1/2. The difference is this negative does not have the exponent applied to it. There's no parentheses here. So this simply equals the negative square root of 64, which equals negative 8. We could say the negative square root of 8 squared, but we should know that the square root of 64 is 8. So negative 64 to the 1/2. The exponent is not applied to the negative, and therefore it stays outside the radical, and we can take the square root of 64, and the solution ends up being negative 8. Part C, we have 64 to the negative 1/2. So we're going to use this relationship again. A to the negative n equals 1 over a to the n. So this is going to equal 1 over 64 to the 1/2, which then equals 1 over the square root of 64. Square root of 64 is once again 8. So we're left with 1 over 8 as the simplification of 64 to the negative 1/2.